Hi everyone. So this is another video on regression. In our previous videos, we just tried to explore just the mere whether there exists a relationship between two variables. Now, on regression, we are going to use an equation as a linear regression equation to uh, establish a relationship between these two variables. So this brings us to the topic regression. So by the end of the video, you're able to know what a regression is, the least squares method for finding the regression equation, the regression line, regression equations. That is, we are going to look at two, that's regression equation y on x and x on y. Also look at how to find the regression coefficients, identification of regression lines. Then we also try to apply whatever you've learned to solve one or two examples on that. So now let's zoom into our main business here. What is regression? Regression analysis. Regression analysis is a statistical method used to examine the relationship between two or more variables. Its primary goal is to model the expected value of a dependent variable, usually denoted by y. You can also call the dependent variable the response or the outcome, based on the values of one or more independent variable, which is also known as the predictors or the explanatory variables. It helps predict, forecast, and infer causal relationships. The goal is to find the values of A and B that minimize the prediction errors using the least squares method. So we would see that in a so we make the videos, we finding A and B. And the main purpose of using the regression to find A is to minimize the prediction errors. That's the difference between the predicted values and the actual values. And let's look at the types of regression techniques. We have basically two. That's the simple linear regression and the multiple regression. So with a simple linear regression, it is used to model the relationship between just one independent variable, that's the x, and also one dependent variable, that's y, using a linear equation. So the form of the equation is in this form. It is normally in this form. Y is equal to a plus bx plus the error term. So now where y is your dependent variable, that's what you are trying to predict or forecast. Then x is your independent variable, the predictor. A is the intercept, that's y-intercept, giving that the value of x is what? 0. So if you put x is 0, you're going to get y is equal to what? A. That's the y-intercept. Then the b is the slope or the gradient. That's the rate at which y changes with x. Then we have the error term that captures the deviation from the of the actual from the predicted. That's the difference between the actual and the predicted values. All right, let's come to another type of the regression technique. That's the multiple linear regression. So when we have two or more independent variables are used to predict what a single dependent variable, then we have a multiple regression. Then the model becomes a multiple. So it is also given by the equation. We have y, that's the one or the single dependent variable. We have the slope, the intercept, that's the y-intercept. Then these are the individual coefficient of the individual independent variable. So we have b1, that is the slope of this independent variable x1, b2, that is the regression coefficient of x2, and in that order. Then we have what the error term. All right, so you would, as we solve example, you know how we go about that. But this video is going to basically focus on simple linear regression. Simple linear regression. All right, now let's look at the least squares method and what it means. The least square method is a fundamental statistical technique used in regression analysis to find the best fitting. We wanted to find the best fitting line through a set of data points. It minimizes the sum of the squares of the errors, that is the residuals, the difference between the observed values, and the values predicted by the regression line. This method is commonly used to solve for linear regression. The least square method is based on a principle that the sum of the squared errors, or the residual, should be made as small as possible so the regression line has the least error. Okay. So the method used to minimize the error is the what? As between the actual and the predicted value using the regression line is the what? The least square method. Now let's come to the regression line. In statistics, a regression line is a line that best describes the behavior of a set of data. It is the best fit straight line that you can draw through or between the point on a scatter diagram. Obviously, a straight line cannot connect all the dots because then you would have to bounce up and down and up and down from one dot to the next, and it will not be a straight line. So we want to be able to draw a single line that comes as close to all the dots as possible. The regression line is the line that best fits. They are saying that the regression line is the line that best fits the data, such prediction is called the regression line. It is also known as the line of best fit. So what they are trying to say is you can have, so you are trying to draw a scatter diagram, you have your y here and you have your x here. And let's say the point are scattered. You can't draw a straight line through this one, and because if you connect this one, you can't draw a straight line. You can't get a straight line. So the regression line is best suited for this. If you want to draw a straight line, you connect one or two points. So let's say if you're connecting this point, the last point here, that gives us a straight line. All right. Then you see that the straight line didn't pass through all the other points. So the distance from this place to this line, the vertical distance from this place is what the error term. That's what the method of least square is trying to minimize. So yeah, the vertical distance from any of the point to the line is our deviations or our error term. And we normally use the least square to minimize such error. All right, we are going to be focusing on two regression equations. So suppose we take two variables, say x and y. Then there will be two regression lines. So we have regression line y on x. That is, we are predicting the values of y given x. And regression line x on y, we are predicting the value of x given y. Okay. And let's come to the regression equation. So regression equation y on x is given by y is equal to a plus bx. Y is equal to a plus bx. Now, our main focus here is to find the value of a and to find the value of b. That helps us to predict the value of y. We can apply the method of least squares. So the method of least square, we have equation 1 and equation 2. So we have summation of y is equal to a times the number of paired variables we have plus b sigma x. Then the second equation, sigma xy is equal to a sigma x plus b sigma x squared. When you expand this one, we would get a. So either you use this to solve for a and b, for which you are going to use an example, or we use this or this to solve for A and B. So regression coefficient, that's the B, y on x is equal to the covariance of x and y divided by the variance of x. And bear in mind that this covariance, that's just y covariance, as we know, can be also rewritten as n sigma x y minus sigma x sigma y divided by n sigma x squared minus or squared. Alternatively, we can also write it as sigma xy divided by n over sigma x over n times sigma y over n, or divided by sigma x squared n minus x over n all squared to find your b as y on x. You have another formula too you can apply. Either you use this when given, or you use this and this. And also find another one, that's my x minus x bar y minus, that's mean of y divided by sigma x minus x bar all squared to find your b. Then how do you find the a? A is the mean of y, so this one too I can write it. A is equal to mean of y minus b times mean of x, as sigma x over n. Okay, another form you can also write the regression equation y on x is this. Sometimes they can just give you the mean of y and they give you the regression coefficient y on x, then they'll give you the mean of x. Just put it this form and make y the subject, then we find the regression equation. Okay, this also stands for correlation. This b here, this b gotten here, can also be found using this formula. Using this formula. And then let's try to prove why you can use that formula. Okay, so we know from our previous studies that to find your correlation coefficient is given by covariance of x and y divided by standard deviation of x multiplied by standard deviation of y. So how, if you want to make covariance the subject here, so your covariance of x and y becomes r times standard deviation of x and standard deviation of y. Okay, now we have this to be your covariance. Let's put this into this. Your regression coefficient y on x now becomes r times standard deviation of x times standard deviation of y, all divided by the variance of x. So the variance of x is given by this. So now this and this are like terms, so you can do the subtraction, or in simple terms, this will cancel one of this one. Then we have y on x is equal to r multiplied by standard deviation of y. For this one, because one is cancelled, we are left with one. Standard deviation of what? X. Then we get this. Let's move to regression equation x on y. X on y. We're also going to so regression equation x on y is given by x is equal to a plus by, where a is the slope, given that y is equal to 0, x is equal to a, then where a is the intercept, that's the x-intercept, given y is equal to 0, is equal to a. And then b is the what? Regression coefficient, or the slope or the gradient. You can also use the same method. You can also use the method of least square to solve it. You're going to have sigma x plus an plus b sigma y. Then you have sigma xy equal to a sigma y plus sigma y squared. Alternatively, you can use this one to find your b, that is your regression coefficient x on y. That's the covariance of x and y divided by the variance of y. So here we had covariance of x and y divided by the variance of what? X. That's when we have y on x, but x on y is rather the variance of y. Also, you can also find the a. That's this one can also be written as a is equal to mean of x minus b mean of y. Another form we can put regression coefficient as writing the regression equation x on y is x minus the mean of x is equal to regression coefficient x on y into bracket y minus the mean of y. Again, this b here, as we indicated earlier can be also written as r times standard deviation of x, or divided by standard deviation of y. We can also prove this one, how we got this, using the same example. So we have r as the correlation coefficient to covariance x and y divided by the variance of x, sorry, divided by standard deviation of x, standard deviation of y. So to find the covariance, r multiplied by standard deviation of x, standard deviation of y. So we also put this into this. Now b x on y, that's a regression coefficient x on y is given by covariance, and covariance is your regression correlation coefficient multiplied by standard deviation of x, deviation of, all divided by variance of y. So we also have one y here, so this one cancel, then this one cancel this one, so we are left with r times standard deviation of x divided by standard deviation of y. So bear in mind, keep these formulas. We would solve examples and we would be applying them one after the other. Now, assuming that we have two regression equations and we don't know which one is x and which one is y, there are some certain procedure we have to follow, and there are some assumptions we would also have to make before we can identify that this, whether the first equation or the second equation is y on x or x on y. So now, suppose there are two regression equations. You have two regression equations. The first one is ax1 plus b1 y plus 0 is equal to 0, and ax2 plus. So we don't know, out of these two equations, which of these two is equation of x on y or y on x. It's not given. We don't know. We don't know. So how do we find out that? How do you find out? In such a case, the following steps should be followed. So if you want to find out whether this first equation is x on y and this one is y on x, or this is y on x and this is x on y. Let's follow these steps, which will help us to, then when we are done, we solve some illustrations on that. So first one is assume any one of the equations as the regression equation of x on y and calculate the what slope, the slope. So since we don't know, we can assume that let the first equation be x on y or even y on x. So if the first equation is x on y, automatically your second equation will be what? Y on x. And if you made your first equation y on x, your second equation should be x on y. When you're done, we calculate the slope, and we calculate the slope of the what? Other one. Now, let's pay attention here. We multiply the slope as x on y by the other slope y on x to find your r squared. So your r squared is basically the coefficient of determination. Your r squared is your coefficient of determination. So let me write it, r squared is equal to the coefficient of determination. So the coefficient of determination is basically we are looking at the variation is given, you're looking at the percentage variation in the dependent variable that can be explained by variation in the what? Independent what? Variable. And it ranges from 0% to 100% or 0 to 1. So you can't get anything above, outside this range. Outside this range. Outside this range. All right. So multiply the two regression coefficient to find your coefficient of what? Determination. Also, let me add this one too. So if this is your coefficient of determination, you're looking at the variation in a dependent variable, the percentage variation in a dependent variable that can be explained by the variation in what? The independent variable. Then your coefficient of non-determination is basically 1 minus r squared. That is your coefficient of non-determination. Okay, now let's come back to steps. If r squared is less than 1, then the assumption is correct, meaning that whatever equation we made here, x on y first, then our assumption is correct. Otherwise, if we multiply these two together and we are getting something greater than 1, then the assumption is wrong and we need to what? Reverse the equation. So if you made this equation x on y and y on what? X, and we later on found that when we multiply the regression coefficient, we are getting something greater than 1, that's r squared greater than 1. Then we need to what? Interchange this what? Equation and make this first one y on x and this one x, y. All right. Note that if one of the regression coefficient is greater than 1, the other must be less than 1. Okay, we are going to see all this thing. We are going to see all this thing as we solve the example. So let's solve the example in our next video.